Hi, I'm Jordan. This is Ryan, and this is our Physics 12 capstone project.
We decided to build a steam engine.
This was the first ever drawing we made of our engine and our plan to make said engine. We had plans to heat up the water in the boiler, send it up through a turbine. When the turbine spins, that would create our power. The excess steam would then come back and feed back into the boiler so that we would have an infinite supply of water. Then followed by the spinning of the turbine would spin a gear, to spin a second gear, to spin a third gear, which would spin our wheels.
So this was our first ever prototype, and it wasn't meant to be anything special. It was just the first prototype that would give us insight on what we were about to do. At this point, it was very simple. All we had here was just a heat source under a boiler.
In this clip, I'm using a blowtorch to test out steam production to ensure that we would have enough steam produced by this to make a turbine spin. We had previous issues using tea lights, which unfortunately I did not get a video of, but the tea lights would not produce enough heat to heat the water up to a vaporized form. We then began using a blowtorch, which worked great, lots of steam production, and later on you'll see we moved to 2 blowtorches. At this stage of our development, we decided we would switch from a turbine to a single piston, as we knew we would have issues getting the turbine to work. So we were looking for materials and possible ways to make a piston instead of a turbine.
And instead of a huge heating tank, we just used a copper pipe, filled it with water, and the blowtorches worked great. So this is our first prototype of the single piston. It was very simple, just a copper piping that connects to the piston.
As you can see here, this was our first attempt heating it up with one piston. You can see we are getting steam production and it is sending the piston up. However, we are having issues getting it to come back down, and the speed it is going up is clearly not enough. At this point, we realized we'd need to make a few tweaks to our design if we were hoping to get this thing working. With a little bit of research online and some insight from my father, we decided to switch to a 2-piston design after this. The 2 pistons would ideally push, as one goes up, the other would fall down, and then we could have a crankshaft to spin our wheels on either end. We also had an issue where the outer diameter of our red pipe was smaller than the inner diameter of the white PVC pipe, so we got around this by putting two circles of electrical tape and 1 circle of Scotch tape around the outside, and then coating it with motor oil to create a seal.
So we were having some problems with the heating and the steam, so we decided to switch to a bigger copper piping. So after seeing this test, we decided that 1 blowtorch wouldn't be sufficient, so we moved to 2, and that improves the project greatly.
As you can see here, there's tons of steam production, and as soon as one of the pistons gets pushed down, the other wants to shoot right back up with the pressure. We have yet to connect it to anything, but you can see one shoots down, the other shoots up, releases the steam through the holes in the side, and then as you push that one down, the other one shoots back up. So essentially, in the next clip you're going to see on here, we attached this crankshaft that creates the spinning motion and pushes one piston up as the other one comes down. So if I push this down, that comes up, this one down, that one comes up. And we originally had our pistons back over here, but we realized we couldn't have these attached to the crankshaft down here with this copper piping in the way. So we instead gave it one more bend, pushed it out here where these little arms could come down on either side, and this allows it to spin.
So for the screws, they were allowing too much steam out, so what we did here is we added glue to prevent steam from coming out, and our shark bites were rotating, so we added this tape here to prevent that. This is our first test with the crankshaft attached to the pistons. We were using 2 blowtorches to improve the steam. That helped, but we still had issues with the crankshaft getting stuck at the top and the bottom.
This is our final project that we will be bringing into class. We never got it to fully function. We had some issues just not being able to get materials that a professional would be able to get. However, you can see here it is producing power, just not enough, fast enough to keep it going. At this stage, we did have our wheels attached to the crankshaft, which was attached to the pistons. The pistons were attached to the steam production chamber. Although it may have been possible to order better fitting parts online, the project was already about $300 to $400 worth of parts, and we decided that that would not be a wise way to spend money.
Although our project is not completely functional, we believe that with the given materials, we did the best job possible.
So down here you can see the electrical tape and scotch tape keeping the seal between the piston. Although this is a good design, worked relatively well, properly machined parts would do a great job to increase the seal, as well as on these arms, the screws, although they do work, parts that were designed for this would work a lot better, as well as our coat hanger crankshaft. It does work, but it doesn't turn over as well as one could hope. As well, we also have plywood wheels attaching in to the coat hanger to create the spinning motion, and our copper pipe.
The person I contacted was Liam Yee. He has a PhD in applied mathematics at UBC and a master in physics from the University of Exeter.
Although we were set to have a Zoom interview on Saturday, in the end it didn't work out. So instead we emailed him the questions, and up next is the answers. The first question we asked was for the pros and cons of a steam engine in comparison to a combustion engine, and the answer we got was the pros to a steam engine were it is quieter since there aren't explosions. You don't need as strong of materials due to the lower pressures, versus the cons are a steam engine needs to be much larger, as well as it is less energy efficient, where a combustion engine is about 35 to 40% efficient. A steam engine is only 15 to 20% efficient. And a steam engine takes a very long time to heat up and get going once steam is starting to produce, whereas a combustion engine will immediately start up. Our second question was, why did they switch from steam-powered trains to diesel-electric? And the answer was more or less that they need to carry less fuel because the diesel-electric is more energy efficient. In addition, these trains are far more eco-friendly than a coal-powered steam engine. Our fourth question was about nuclear reactors and how water and steam are used in them, and whether or not water would ever be replaced as one of the things that is used to make the turbine spin. In short, his answer was no. Water has a very high specific heat capacity and can also be used as a cooling, and it is very cheap to get.
This summarizes our Physics 12 capstone project. Thanks for listening to our video.